Okay, we're going to look at differentiation. So our function or our graph, basically Leibniz notation, Newton notation, doesn't make any difference. F of x, x to the n, y equals x to the n. So f dashed x, the differential, or dy by dx, you bring the power down and multiply, so it's n, x, and reduce the power by 1, so n minus 1. So n x to the n minus 1. Power down, multiply, reduce the power by 1. So differentiating the following, find f of x or find dy by dx. So this first one, f of x equals x to the power of 10. So when we bring the power down, so we multiply by 10, so f dashed x is 10 x to the 9, reduce the power by 1. Here, y equals the square root of x, so y equals x to the power of a half. Remember, it's got to be in differentiable form. We've done those last week. So power down, multiply, reduce the power by 1. So it's a half x to the negative a half. Putting it back in the same form as the original question, it's 1 over 2 root x. For the next one, f of x equals cube root of x to the 5. So x to the 5 thirds, now it's in differentiable form. Bring the power down, multiply, reduce the power by 1. So it's 5 thirds x to the 2 thirds. So it's 5 thirds x to the square root, cube root of x squared. For the next one, y equals 1 over x cubed. Remember, in differentiable form, it's y equals x to the negative 3. So dy by dx equals negative 3 x to the negative 4. 1 less than negative 3 is negative 4. So that's negative 3 over x to the 4. Looking at the next one, y over square root x to the 7, which is 1 over x to the 7 over 2. Remember, power is 7, root is 2. So it's f of x equals x to the power of negative 7 over 2. So f dashed x is negative 7 over 2, x to the negative 9 over 2. Putting it back in the same form, negative 7 over 2, square root x to the 9. So, what happens when we have a multiplier at the front? Well, nothing actually changes apart from we multiply by bring the power down and multiply, and we reduce the power by 1. So f of x equals a x to the n, or y equals a x to the n. F dashed x would be a times n, x to the n minus 1. So if we're looking at this first one, f of x equals 1 over 3x squared, which is 1/3. That's our multiplier, x to the negative 2. So power down, multiply, so negative 2/3 x to the negative 3, which is negative 2 over 3x to the 3. For the second one, y equals 3x squared minus 2x. dy by dx is 6x to the 1 minus 2x to the 0. So x to the 1 is just x, and x to the 0 is just 1. So hard kind of rule to remember, if it's a singular x, so if it's x to the power of 1, it's going to disappear and leave you the number at the front. Okay? If it's a number, you'll see that in a minute, the number just disappears. Okay, so f of x equals 5 over 4 square root x cubed. So that's 5 over 4 times 1 over x to the 3 over 2. Root is 2, power is 3. So f of x equals 5 over 4 x to the negative 3 over 2. Power down, multiply, reduce the power by 1. So 5 over 4 times 3 over 2 is 15 over 8. So f dashed x is negative 15 over 8, x to the negative 5 over 2, which is negative 15 over 8, square root x to the 5. For the last one here, y equals 6 minus 5 over cube root x plus 2 root x. So that's 6 minus 5 x to the negative a third plus 2x to the half. So the x, this disappears, a number just disappears. Bring power down, so negative is positive. 5 thirds, x to the negative 4 thirds, plus the half comes down and multiplies the 2 to give you 1. Take 1 off the power, you get negative a half. So putting it back in the right form, 5 over 3 cube root x to the 4 plus 1 over root x.